All right, tonight we start our units on quadratics, and I can't wait. I know the title says I can't function, but we are going to function, and today we're going to look at Fred functions. We're going to look at parent functions. And so we just finished up our unit on transformations, and so we're going to apply those transformations now, not just to points or polygons. We're going to apply transformation rules to quadratic functions. So let's go ahead and get started. And Sarah, that joke's for you. Okay, so to the right is the graph of a Fred function. So I know that this is a function because it passes the vertical line test. So if I draw vertical lines, if I take my arrow, draw a vertical line down here, it only passes, my red arrow only passes through that Fred function once each time I make that vertical line. So let's just review what a function is. And if you remember from last year, a function is a relation or a set of points where each input has exactly one output. And I'm going to type that in so it'll be easier to see. So it's a relation. And remember, a relation is just a set of ordered pairs. So it's a relation where each input has exactly one output. And basically that means that my, let me fix that so we can put that someplace nice. That means that none of the x values can repeat. I can have y values that repeat, but I can't have x values that repeat. So a relation is a set of ordered pairs. A function is a relation, which is a set of ordered pairs where each input has exactly one output. And yes, I know I spelled output wrong, so let me fix that. So again, to review what domain is, domain, and we did this, domain and range was pretty much our last set of notes from the last unit. Domain are all x values of a function. And they could be the x values of the relation, but right now we're just going to work on x values of we're just going to be working with functions. Okay, and again, range is all the y values of a function. So all y values, and again, we're just working with functions of a function. So we're going to take a look at Fred the function. Fred the function is up there. So range, all y values of a function. Domain are all the x values of a function. Okay, so let's take a look at Fred. And I realize my letters are moving with Fred, so I apologize. I'll get those out of the way in a minute. We want to look at what is the range of Fred. So again, range in this case are the y values. Well, in every case it's the y values. So I'm going to go ahead and box in my function. So I'm looking for the range. So my low point of Fred is down here at -2. My high point of Fred is up here at +1. So if we want to write the range of Fred, let's go ahead and put the range of Fred in our notes. Sorry, my all x values keep on popping up, so let me get rid of them. There we go. We can write Fred's range. I'm going to write it as an interval. The low point is -2, is less than or equal to y, is less than or equal to 1. And we could also write it in this notation. It'd be -2, 1, and boxes on the end because there's endpoints there, no open circles. So how many points lie on the Fred? So how many points can we count between -2 and -1? And that's an infinite number of points, because that includes all the decimals between and including -2 and 1. So can we list them all? Well, I don't have a lifetime to list them all, so the answer is no, because there are too many, because it's infinite. So we're going to take a look at some key points. So the third question on there says, what are the key points that would help you, or would help us graph Fred? So let's go back over here to Fred. And these key points I'm going to refer to as the characteristic points. So let me erase these yellow lines. We're going to look for the key points that will identify how could we graph Fred if we just had some points. So let's take a look at Fred. So we want points that end up as integers. So Fred is f of x, and just trying to find a marker. Here we go. So we can use this point right here, which is -1, 1. We could use 0, 0. We can use 1, -1. We can use 2, -1, and we can use 4, -2. So these are what we call characteristic points. If we were going to describe the function Fred, what are the characteristic points? And those are the 5 characteristic points. So we're going to go ahead and list them over here. See you later, Fred. We'll be back. So what are the key points that would help us graph Fred? Well, the key points, we already said, were -1 and 1, the point 0, 0, the point -1, -1, 2, -1, and 4, -2. And there are an infinite number of points between all these two. And we're going to call these points, when it says list the characteristic points, these are called characteristic points. Do you think that word's important because it's bold-faced? It's got quotations and I've underlined it and boxed it in red? I would say yes, that is important. Okay, so we're going to use the graph to evaluate the following. So take a look at these down here. We're going to use the graph to find f of 1. So I'm going to go ahead and bring Fred over here so that I don't have to keep on moving the graph back and forth. So let me go ahead and put Fred in there. Okay, there's Fred. Say hi to Fred. So we need to find f of 1. So what does f of 1 mean? F of 1 means that when x equals 1 on this Fred function, we are trying to figure out what does y equal. So let's take a look at the Fred function. So when x equals 1 is right here. What does y equal? So there's no Fred function up here, so we're going to go down. And when f of 1, or when x is 1, y equals -1. So this is the point 1, -1. So when f of 1 is -1. So when x equals 1, y equals -1. So let's take a look at f of -1. So again, we're looking for -1. It's right here. So where does it hit the Fred function? If we go to, we need the y value. So if we go up right here, again, we're not going to go down because Fred's not down there. Fred's up here. So when x is -1, that means that y is +1. So again, this is saying when x is -1, we are trying to figure out what does y equal. And we did, it is +1. So this one's a little backwards. This one we have to figure out what x is when y equals -2. So we're going to do the same thing, but this time we're going to go on the y-axis. Here's y equals -2, where if we go left, there's no Fred function. If we go to the right, when y is -2, what is x equal to? X is equal to 4. So f of 4 is -2. And finally, f of 5, when x equals 5, what does y equal? So again, let's go back and say hi to Fred. So when x is 5, what does y equal? It doesn't hit the Fred function. So we're going to say that this is not applicable. Doesn't work for our Fred function. So we're going to be taking a look at Fred for the next couple days. So you might well get used to him, introduce yourself, say hi. Okay, so here are the 2 video questions for tonight. For multiple choice question 1, fill in the blank given the graph below. So this question again is asking we need to find this number, f of what? So we are looking for x when y equals 5. And there might be more than one answer, so be careful. And then number 2, what is the domain and range of the following graph? And you don't have to write that one in interval notation. You can just write it using the brackets or the commas. It'd be easier to put in the Google form. Have a good night.